Hi everybody, thank you for watching my video on physics. The video today is an extension to my previous video on mathematics and physics. I shall provide the answer to my last question in which I asked you in the equation C equal to Q over delta T, what happens to the heat capacity C when delta T equal to 0? In pure mathematics, variables in an equation need not have any meaning. For example, in x equal to 2y, the variables x and y can represent anything. In physics, all variables have meanings. On the other hand, a symbol may or may not be variables. For example, if the equation x equal to 2y is written as x equal to k times y, then k is a constant. Only x and y are variables. In physics, variables are further classified into independent variables and dependent variables. In simple terms, it is the cause and effect. Independent variables are causes, and dependent variables are effects. For example, in an experiment, we may vary a physical quantity to change the result. The physical quantity which is varied in the first place belongs to independent variable. In heating a liquid, for example, the heat supply Q is something we can control by varying the time interval in which the power supply is turned on. Thus, Q is the cause. It is an independent variable. Here, the effect is the temperature change delta T. Result shows that delta T is directly proportional to Q. In physics, you need to identify which variable is a constant. For example, in heating a liquid and in the equation C equal to Q over delta T, the heat capacity C is a constant. Therefore, an increase in Q will cause an increase in delta T only. It cannot cause any change in C. In fact, you should write the equation as Q equal to C times delta T. Here, since C is a constant, an increase in Q will cause an increase in delta T. Now let's modify the experiment and use another liquid with a smaller heat capacity. We shall also use the same heat supply Q. Now, in the equation C equal to Q over delta T, Q is a constant, but C is a variable. A smaller C will cause a larger temperature change delta T. In solving problems in physics, we must understand the conditions clearly before we can make a conclusion. In the last video, I asked you what happens when delta T equal to 0. If you put delta T equal to 0 in C equal to Q over delta T, you may end up with a conclusion that C is undefined. This is unacceptable because heat capacity always has a well-defined value. The proper way to deal with this problem is to write the equation as Q equal to C times delta T. Since the question does not mention another object, C is a constant. Therefore, for delta T equal to 0, Q is equal to 0. It implies that no heat is supplied to the object. Since delta T equal to 0 means that there is no temperature change. This is perfectly correct. Without heat supply, there is no change in temperature. Simple, right? In summary, this and the previous video tells you about the difference between pure mathematics and physics. In physics, the cause and effect must be identified clearly. Some variables will affect the others. They are the causes. The result is determined by the cause, but not the vice versa. On the other hand, in dealing with mathematics, remember, in order to avoid division by 0, you should rearrange the equation so that no division by 0 is involved. When the equation is written as Q equal to C times delta T, you can put delta T equal to 0 and get the final result safely. Before we end, I would like to ask you a question. For a given heat supply, what are the factors that determine the final temperature of a liquid? Be the first to write your answer in the comments below. Also, you may comment on the answers of other people. I hope this video can help you apply your knowledge in mathematics in solving physics problems more correctly. Thank you for watching.